Comparison between series hybrid, parallel hybrid, and power split hybrid. In the series hybrid, load following control strategy is applied as the motor provides all the power and torque demanded from the road. So here, motor will provide the required power so that it can fulfill the motor load requirement. Engine provides the power and runs the generator to regulate the battery state of charge at a certain constant level. So here, engine is not directly coupled, so it will always provide power through the generation to the battery. In parallel hybrid, a rule-based control strategy is applied to regulate the motor turn on and turn off time, power assistance, and regenerative braking. So here it is possible to turn off the engine and turn on the engine so that it can provide the maximum efficiency. Also, it can have the power assistance in the parallel hybrid by the engine, and also the system can be kept on the regenerative braking mode. So these facilities are available. In the power split hybrid, lower fuel consumption control strategy is combined with the performance propelling control is applied to achieve the best engine operating regions. In series hybrid, the motor provides all the power required from the road load while the engine operates to charge the battery. In parallel hybrid, the engine provides all the power at constant cruising speed. So engine can directly provide the propulsion or the powertrain or torque. In the power split hybrid, the two electric machines regulate the engine speed and the power in its fuel optimum regions by using one serving as a generator and other serving as a motor. So system can be operated at an optimum level. Both high engine efficiency and high vehicle fuel economy can be achieved in the power split hybrid configuration. Comparing the engine power, the series hybrid electric vehicle requires the highest engine power due to the power losses occurring in the two power conversions. So in series, the power is provided by the IC engine and then it is generated by using a generator, then it is given to the battery. So these conversions are there, and then finally the motor will drive the vehicle. So for this, it requires the high power engine. Lowest engine power is required for the parallel HEV hybrid electric vehicle because of much lower power losses, and engine power required for the power split hybrid is in the middle range. The engine efficiency depends on engine operating points for a given power output and engine technology. The series hybrid electric vehicle and the power split hybrid electric vehicle have a relatively higher engine efficiency as compared to the parallel hybrid electric vehicle, because in parallel hybrid electric vehicle, the engine is always coupled with the transmission output shaft, and thus the operating points are not regulated in the fuel optimal regions. Now, fuel economy. Series HEVs have significant losses in the power conversion from mechanical power to electric power and back to mechanical power again. So losses are there in series HEV. The parallel hybrids have relatively smaller electric systems compared with conventional IC engines. So the fuel economic is higher on highways because the engine operates with higher efficiency and the electric machine assists with the power performance. As this parallel hybrid is electric assisted vehicle. The electric machine also functions with a certain degree of regenerative braking to retrieve the kinetic energy back to the battery. The fuel economy and engine efficiency of parallel hybrids on city drives are compensated due to the low efficiency of the engine. The power split hybrids combine the benefits of both the series hybrid and the parallel hybrid, and they have balanced solution for the driving. Satisfactory engine operating efficiency and vehicle fuel economy are achieved on both city drives and highway drives. So power split is well suited for the city driving as well as highway drive cycles. Both engine speed and torque can be decoupled from the transmission output shaft because of the power split arrangement. Less power are lost in the power convergence due to the integration of mechanical power and electrical power in power split devices. Power split hybrids have lower fuel economy on highways than in cities due to less regenerative braking opportunities and losses in electric motor and inverter at higher speeds. The pros and cons of hybrid electric vehicles. We'll compare the advantages and disadvantages of three hybrid configurations of vehicle: series hybrid, parallel hybrid, and power split hybrid. The first point is energy recovery by regenerative braking. Series hybrid, it is accomplished by the traction motor, sufficient regeneration capacities there. In parallel hybrid, regeneration is accomplished by the electric motor, limited regeneration capability because of motor and battery capability or size. Motor speed is promised by the gear ratios. In power split hybrid, it is obtained by electric motor and limited regeneration capability because of the lower battery capability. Thus, series hybrid, they provide the sufficient regenerative capability because of the size of the motor and the battery. Engine start stop, another point. In series hybrid, can shut off IC engine at any vehicle speed and load. Controlled by the generator, decoupled start stop controls with high quality are obtained. In parallel hybrid, usually requires a disconnect clutch and can shut off IC engine at any vehicle speed and load. Without a starter motor, engine start is challenging and may impact driving experience, that is a drivability. In power split, also it can shut off IC engine below certain vehicle speed because of the transaxial kinematic constraints controlled by both electric machines. Good start stop quality in power split hybrid. The next point, engine operating point optimization. In series hybrid, it can optimize in both speed and torque, can optimize IC engine technology and generator technology. In parallel hybrid, it can optimize torque, complicated with gear selection and shift controls. In power split, engine operating point can be optimized in both speed and torque, but compromised by electric losses Clushless CVT for smooth operations is used. Overall strength and weakness. Good for very transient drive cycle, compromised efficiency in highway cruise or steady state because of double energy conversion, that is mechanical, electric, and then mechanical. Higher requirement on the traction motor, higher requirement on battery power. For parallel hybrid, good for highway and steady state, compromise fuel economy in transient driving cycles, lower requirement on the traction motor, lower requirement on battery power. It is more cost effective. Trade-off between balance city. Excellent drive, fuel economy, driving cycle efficiency compares can see there is there idling high efficiency acceleration parallel session can see high efficiency also power split parallel hybrid idling stock and as compared to has excellent has high efficiency efficient parameters driving performance in the acceleration and